So only 13 students. Okay, so we'll continue with our programming examples, and today we will do on turning. So we have seen three examples on CNC milling. The first example was only contour milling, external milling, having angle as well as arc. Then second example was with the holes with the use of G81 drilling cycle. Third example was having slot and with the help of G41, G42 as well as without the help of G41, G42. So now we'll go for turning. Either you draw this drawing or try to understand this drawing very well along with the dimensions. Yeah. So this is a component, only the half portion is shown, and I hope it is clear. I'll give you a minute to understand this component. It's a round one. It's a round component. This is the center line. So I hope this drawing is clear. So this is there is a small radius over here, followed by taper straight portion. Then again you have a radius here and angle, and followed by a straight portion. This diameter is 200, and there's a taper here at angle 70 degree, and then again a straight portion and again a small chamfer. Then you have a radius. See, there is a taper here at 30 degree, followed by radius, followed by taper, and followed by straight portion. And all these are, this is a smooth curve. So this is tangential radius, right? So try to understand the lengths and try to copy this diagram. It will take 2-3 minutes only, not much, so that when you read the program, that time you understand. So I hope you are done with this. You have drawn it. So this diameter is 50, and there is a taper at 15 degree followed by radius. So you can get this diameter. You can calculate it, or you can take the help of control. Now you have to remember, in case of CNC lathe, the x0 is always on the center line. That you have to remember. X0 is always on the center line. This is a center line. This is a break line, and this is hold in a 3 jaw chuck. And Z0 is on the face, not necessarily always on the front face. Z0 can be here also, anywhere. Z0 can be anywhere on the line, but obviously it is convenient to take Z0 on the front face instead of taking it on the back face. You can take it here also on the back face. Of course, in between though you cannot take. So either you have two options, either on this front face or on the back face. And obviously it is convenient to take it on the front face. So by default, in case of CNC lathe, the X0 and Z0. Remember now here, this is your Z axis. You remember this properly. This is your not X axis, this is your Z axis, and this is not your Y axis, but this is your X axis. दो एक्सिस बराबर ध्यान में रखो. दिस इज एक्स एंड दिस इज जेड. ये जेड है और ये एक्स है. दैट इज वन थिंग यू हैव टू रिमेंबर. बाय डिफॉल्ट x0 and z0 will be over here, which is shown by point p1. And third most important thing that you have to remember, that in case of CNC lathe, it is always a diametrical program. Diametrical program, that is from here to here, the distance, this distance is 25, but you don't give 25, you say x25. You don't say x25, you say x50. Here you say x100. Here you say x180, 185. Here you say not x100, you say x200, x200, x185, x75, x50. Nobody says this is 25 or this is 37.5. No, because 100% all the drawings, the diameters are mentioned. Nobody mentions the radius. So in case of CNC, the three important things, that is, it is always a diametrical programming. It is always a diametrical programming. X0, Z0 is over here. It is all, and X0, Z0 is here. It is always a diametrical programming. Now remember this distance. So this is Z0. So this will be Z minus 50. This point will be Z minus 60. This point will be Z minus 100. So if I ask you the coordinates of P1, the coordinates of P1 will be x0, z0. Again and again I am telling that z is in longitudinal direction, x is in transverse direction. Like our normal coordinate systems, xy coordinate system, this is your y and this is your x. But in case of all CNC lathe programming, this is your z and this is your x, and it is diametrical programming, and the x0, z0 is here. So that's why your lathe programming is very easy. So coordinate of P1 is x0, z0. Coordinate of P3 is how much? That is z. P3 का coordinate is z minus 102. See, this is z0. So all these dimension will be minus. So this is z minus 102 and x will be 200. Coordinates of P3 will be x 200 and z minus 102. Coordinates of P2 will be x 200 and z minus 150. Coordinates of P2 will be x 200 and z minus 150. Okay, so now we will, the next is you have to prepare a table. Okay, first in the answer paper you need to draw this sketch. Don't think that it is drawn in the question paper, so answer paper me it is not required. No, it is required in the answer sheet. Show x0, z0 and then prepare the table. In the table you write down operations. Hmm? Like you may have different operation. Now here it is the only turning. So you can say OD turning rough. Then you can say OD turning finish. Then suppose if there is a threading operation, then you can say threading, because for threading the different tool is required. So then there may be drill here. So you say fourth operation drill. Then there may be bore. So you say rub bore. There may be groove. Okay, on the OD. So growing. There may be groove on the face. So face growing. So for every operations, now how do you split the operation? The moment you change the tool, you change the operation. Okay, so now here this can be done with the two tools practically. One is your OD turning rough and OD turn. Second is your OD turning finish. But even if you write only one, that is sufficient. Huh? Had there been some other operation like say groove, then operation number 20, hmm, grooving, and then under tool you have to write grooving tool. If you know the nomenclature or specification of the tool, fine. If you know the specification of the tool, it is fine. Otherwise, you can simply say grooving tool, facing tool, like that you can say. Because we understand that it's very, I mean, it's not that easy to remember all the you know nomenclature of the gluing tool, of the threading tool. So you can simply say threading tool. So now when you make the table, so you say first is your operation, that is say OD rough turning. Then next is your tool, that is say turning tool, OD turning tool. Then hmm, whether HSS or carbide that you write. Then you write your speeds and feeds, and the most important, you must write the tool number, whether it is T01, T02, that is must tool number, so that examiner understands that whatever you are written, that is T01, T05. Suppose if you are using 5 or 6 tools, so examiner understands that it will be threading tool or it will be growing tool. Hmm. So that table is must, whether it is milling program or lathe program. Now here it is just a simple program. Hmm. So now G10 again, this block you replace. Hmm. First block you must write your G28 similar to your milling. So you write G28 and then G91. Some mistakes has been done purposely. G is always capital G28, G91, then X0 and Z0. That means this will go to the and say end of the block. This will go to the reference position or to the home position. G28, G91, X0, Z0. Reference position, that is X0 and Z0. Hmm. So this is your home position, reference position. In X direction, that is this, and Z, that is this. So generally again same. In the lathe also it is over here. If this is the plane, suppose in which you are doing turning, say XY plane. So home position is generally here, X0 Z. Hmm. Then you can cancel. Our next practice is to cancel all the offsets. So we will say G80, hmm, G, G80, that is can cycle cancellation. Then you can use G40, okay, and you can select your G90. You can also cancel your tool offset, that is T0 means uh, tool offset cancel. This is a way of safe program G80, G40, G90, T0. Hmm. Then this is wrong. Okay, so you can delete this because it is going Z minus 200. So Z minus 200 rapidly जा रहा है तो किधर भी तो dash मारेगा. I'll simply make it undo again and show you again. See, Z10 P0 Z minus 200. So suppose now in this case your Z0 is here. So Z minus 200 means यहाँ से 200 minus में जाएगा. Suppose if this is the position of x100, यहाँ से with respect to this line it will go 200 minus. So it is going to dash. So that's why I deleted this block which is wrong. Hmm. Now T03. Now what is the mistake here? That there is no tool change. So you say here M06. M06. Remember the difference between O and 0. So this is M06. Tool number 3. So tool number 3 will come. Tool change will happen. M06 is nothing but a tool change. Tool change will happen. Tool number 3. And this 03 is nothing but the offset. It will take the offset. It will go to the tool library and it will take the control will take the offset from 3. You can have T0, you can have T03 like this. So you can write T0305. Nobody does like this because this means tool number 3 and it will read the offset from row 5, which is actually confusing. So you may make mistakes. So it is always better than this. Or you can use the offset form. Say now suppose on the lathe machine there are not more than 12 tools. So you can take the offset from say row number 20. Row number 20 say you can take the offset. This is safe. So tool number 3 and offset is, so one tool can have many offset 20, 21, 22, 23 like that. Hmm. But provided if you are using many offset, if you are using only one offset, then it is safe practice that you take offset from row number 3 only. So tool number 3 and row number 3. Hey, Zui. This is a charging का issue. So here you can take the offset upon 3. This is a safe programming. Now G50S200. Now this is again here there is a mistake here. So 2200 is nothing but the RPM. So here M03 S 2200. Here it is written that it is profiling. Profiling means it can be used for this facing turning as well as it can be used for this profile turning also. So now next is G96. So G96 is nothing but constant surface speed. So constant surface speed G99 is nothing but return to the R level. Now S230 is cutting speed, that is V, cutting velocity. F is 0.12, that is millimeter per revolution. Then M4, M8, M200. So again this is very long. So you delete this M4, delete this M200 because more than 2 M codes are not allowed. Now here cutting speed is 230. So now G96 is nothing but a constant surface speed. So as per this cutting speed, the RPM will be calculated. Huh? So you need to fix up the maximum RPM. Okay, so that the accident will not happen. So we will say here G92. So G92 is nothing but maximum speed. So it will not go beyond this. So we will say S4000. Means what if the now what is G96 and S32 is 230? This is nothing but the velocity. Okay, so V is equal to pi d n upon 1000. So V is 230. So what happens when you do facing or when the diameters are very low? So that time the suppose when you are doing facing and if the tool approaches to the center lens, तो यहाँ पे आपका diameter 0 है, so speed will be infinite. So the machine will try to achieve maximum speed, infinite speed. So it will whole thing will vibrate and either the workpiece will fly off or some damages will occur. So in order to prevent these damages, we fix up the machine speed, that is G92 S4. So whatever may be the diameter, whatever diameter may be the smaller diameter, the speed will not increase more than 4000 RPM. So G92 S4000. And since we are using millimeter per revolution, we need to use G95. So we'll say G95, which is nothing but millimeter feed rate in millimeter per revolution, and G94 is feed rate in millimeter per minute. Now the tool will come rapidly X0Z3, X0Z3. That means X0 is along this line, and Z3 is nothing but 3 mm from this 3 mm from this face. That is what is your Z3 is. Hmm. Then G1Z0, G1Z0. So now it will come in feed. So from here Z3 3 mm यहाँ पे था. It will come in feed slowly. Z0. Then A90 R6. A90 means this is your 90-degree angle, and R6 is nothing but this corner radius. Alright. And you have to give the endpoints. Endpoint is nothing but X50 and Z minus 25 and A165. A165, how one A165? You have to always give angles in this direction. Okay, so that will be nothing but 180 minus 15. So that will be 165. And now this is corner radius. So before that, you have to give G1 Z0 होने के बाद you need to give this diameter. Okay, so you need to calculate this diameter. So this is 50. So you can say around x 15. You can say around x 25. So x x 25 is your end of block. Z1 Z0 point P1 is this. So I'll say x25. This you need to calculate. Hmm? I'm just giving you randomly. This point is nothing but this. यहाँ पे. Hmm? And from Z0 x0 the tool will come to this point x25, assuming that this is calculated, and then it will take the corner radius, that is nothing but this r6. Okay, and then it will do this angle followed by a 180. So this angle is 180. So now this machining will take place 180 ka, and diameter is already given x50 and angle is 180. Then this diameter, that is x is how much, 75. So this is x75. What about z? Hmm? Now this z, if you see here, this is 50 and there is a chamfer of 1. So 50 minus 1, so that will be 49. So z will be minus 49 and a90. So this is little complicated, this command. Hmm. So look here now, what is happening here? Here what is happening, that tool is going to 75. Okay, then z is at a distance of 49, that is minus 49. Then angle is 90, that is this turning is going to happen. And then C1 is nothing but the chamfer. So chamfer of 1 mm. C1 is nothing but a chamfer of 1 mm. 1 mm chamfer will be done here. Then Z minus 60, so that is this point. Z minus 60 is nothing but this 50 plus 10, so that is minus 60. Z minus 60. If you wish, you can write down, or you can take the screenshot. So if you want to take screenshot, this is the entire program. Okay, so now C1 हो गया, Z minus 60 is also done. That is, now at block number 110, we are here at this point. Okay. Now we have to do radius turn. So here what is A150 and R50. So now 150, that is, there is a taper here. So 30 degree, and we have to give angle in this direction. That is counterclockwise. So 180 minus 30, that will be 150, and this is the radius here. Okay. So how to give this? Either you can calculate, or if you don't want to calculate, then you can use this command. So A150, that is go at an angle. Okay, and then there is a radius of 50. Hmm? There is a radius of 50, that is R50. Hmm? And R50, how R50 will be machined? That next point is your C, X185. See, R50 is between this degree. That means you need to give this degree also. So how do you give this degree? You have to specify this point, that is X185. All right, and then this distance, that is z minus 100. This point is x185 and z minus 100, and you need to give the angle also. What will be the angle? X180 minus 70, that is 110. Okay, so now in these two blocks, what is happening? That it is going to turn this taper, going to do this radius, and it is going to do this taper also. And all this point, and this point, and this point. This point we are giving, and this point also we are giving. This point is what? It is x75 and z minus 60. This point is x185 and z minus 100. And in between, we are doing machining of two tapers and one radius, right? Two tapers and one radius. So that is given by this. Then A90, that is go along this A90 and do a chamfer of 2 mm. That is this 2 by 45 degree. And of course, you need to give the point P3. C2 is nothing but a chamfer of 2 mm. And you need to give this point, that is x is 200 and z is minus 100 plus, that is this x is 200 you need to give. And what is going to happen here? Z, see, I hope this block is clear. That is, you are going 90 degree and you are going till point x200, and here you are doing a taper, chamfer of 2 mm, and then you go straight 150 down. Okay, that is up to this point. So this will be z minus 150 and angle will be 180. So this is turning like this. Angle will be 180. That is this. Hmm. Then G0 X250, X250 and Z200. So Z200 is equal to this. It will be 200 in positive side and X250. So that means the tool will be radial direction. It will be 25 mm above. So it will be somewhere here. Then you, that means you are retracting the tool. Hmm. And then at the end you can say G28, G91, X0, Z0. So reference retreat. So this is how. So here the critical points are, that is this point which you are not calculating. Control is calculating this point, that is this taper and radius. One point is here, then this radius and taper, this, and then again you have 2 points here. It is this taper and radius and this radius and this straight line. Now here you can avoid this x25 because you are giving this corner radius r6 and you are giving a90. So this is not required. X25 is not required. Why? Because Z0, Z0 के बाद the machining is done 90 degree. Machining is done 90 degree and corner radius is r6. So the control will calculate this point as well as this point. Remember. Hmm? And then you are giving x50 z minus 25. X50 z minus 25 and at an angle of 180 minus 15. So that is 165. Okay. So with the help of corner radius, that is C1, A and R, that is R6, A165 and C1, you can avoid calculating this point. These points are not required to calculate. Another way is, that is, suppose if you don't want to use this A or don't want to use this R, hmm, then you need to calculate this point. And you have drawn this diagram on AutoCAD, so you can get this point. This is simple because most of the times you get the points on the drawing, because in this way it may happen that it may give some error. Hmm. So it is safe to calculate this point. Okay. Then here one more point, that is this, and one more point. So 4 points coordinates you can get it on your modeling software. Then now you say Z01, Z0. Then suppose if this point is 25, then you say G1 x 25. Now what about this radius? So now the tool is going how, in this direction, isn't it? Turning is like this. So it is counterclockwise. So counterclockwise is what? G02 or G03? It is G02. So what you have to say G02, then you have to give the end points, that is X and Z, and say radius R6. Okay. So suppose if this point is say X 30 and say Z minus 6, then what you have to say G02 X 30 Z minus 6 and R6. Okay. Then you can say G1 X is 50 and Z is minus 25. Then you say, that is this, in this way you are totally eliminating angle command. You are totally eliminating C command, that is chamfer command. Then here you can say G01 X50 Z minus 49. Okay. Then you say X, how much it will be? 75 minus chamfer is 1 1, so 75 minus 2. So you can say G1 X is 73. Then here you can say G1 X how much? 75, and Z will be minus how much? 50. ये 49 हम लोग already किए हैं. Okay, then you say G1 Z minus 60. Then you have calculated this, so you can give this point G1 X something and Z something. Then this will be your G03, that is clockwise. Say G03, you give this point X and Z and say R50. Then you give this point, that is G1 X is 185 and Z is minus 100. Okay. Then this straight point, that will be G01 X is how much now? 200 minus chamfer 2 का है. So 2 4 minus. So it will be 196. So G01 X is 196 and Z is minus 100. Then you say this point. So this will be X is G01 X is 200, Z is minus 102. 100 plus 2. Z is minus 102. Then straight away here, that is G01 Z minus 150. Then you can say next block में G0, you can stop the spindle, that is M05. Then next block में you can stop the coolant, that is M09. Then you can reference return, that is G91 X0Z0 and say M30. M30 is nothing but reset and rewind. Hmm. So I have explained you two ways. That is, one way is use this command, that is angle, chamfer and radius, in which you don't have to calculate. Another is simple and safe, is you get these coordinates from your modeling software and choose those. It is very safe. And then third is you can use the compensation, because any tool will have a nose radius. यहाँ पे nose radius रहेगा, and the nose radius is as small as 0.4 and as high as 2 millimeter. So if you are doing rough turning, then your cutting point always goes on changing. Your cutting point always go on changing. So that's why you need to use the radius compensation. Now how the tool is traveling, it is on the right hand side. So you must use, when you are touching this, when during this first block, that is when you are bringing the tool here, Z3 से G1 Z0, so that time you must use G40. तो आप G40 use करो. Now G40 is nothing but cannulation. So we are moving the tool on the right hand side. So it will be G42. G41 is left, G42 is right. So here आपको G1 G42 use करना पड़ेगा. G42 Z0. So G42 Z0. The tool is moving on the right hand side. Then at the end here, that is at the end, when you say G1 Z is minus 150. Okay. So that time when you are writing next block, when you are writing M05, that is spindle stop, so that time you can say G40. So that means your offset cancellation. or you can write that G40. You can lift this to a little bit, like you can say here G0 X is 225, safe to be safe, and Z is minus 150. So the tool will come somewhere here and say G40, and then also write M05 in the same block. So M0 G0 M05 X is 225 and Z is minus 100 and say G40, and after that you take tool to the reference position. So this is what is your safe programming case. We'll discuss some more turning programs. Now you can enjoy your break. If you have any doubt you can ask. So this is one simple program, two more. Hmm. So this is with the radius. Thank you very much. If you have doubt you can ask, otherwise we can take break.
So why we didn't use G50?
Uh, you want to ask something?
Ah, yes, sir.
बोलो ना.
So why we didn't use G50 in N30 command, sir?
Can you speak loudly? Yeah. हाँ बोलिए. Yes,
So
Nader.
why we did so why we didn't use
Why?
G50?
G50 actually in some machines G50 it locks the spindle speed, but that varies from control to control. So instead of G50 I have used G92. So G50 and G92 the function is same, but the G92 is common. Now what is the function of G50? It doesn't allow the spindle speed to increase. So
Yes,
we are locking the spindle speed. So in our this program, if you use G50 S5 4000 or if you use G92 S4000, the spindle speed will not increase more than 4000, because I told that we are using G96. G96 is constant surface speed, and there we are giving velocity at say 200 or 230 in this program. So V is equal to pi d n upon 1000. Now what happens if the diameter is 0? Your n will be infinite, isn't it? Are you understanding, Upkar?
yes, sir.
So now n will be infinite means what? The machine speed will increase tremendously. So it will start vibrating. So if your machine foundation is good, then it will take it. If it is on just on the pads, or if you have just kept it on the floor, because most of the CNC machines are kept on the floor with some vibration pads. Nobody does foundation. Then your machine will start vibrating. Because of the vibration your component will become loose and it will fly off, so accident will happen. So that's why what we lock the spindle speed 4000, but 4000 is sufficient. So G50, or if you are using G92, your spindle speed will not increase more than 4000. Is that clear?
Okay, sir. Yes, yes,
Yeah,
sir.
that is what is called the spindle speed preset. Spindle speed preset means your spindle speed will not increase above 4000.
Yes, sir.
4000 means we have written there. Yes, please.
Yes, sir.
Anything else?
Excuse me,
No,
sir.
sir. Thank you, sir.
Yeah, Renan. Yeah.
Yes, sir. What is C1 and C2?
C1 and C2, that stands for the corner chamfer. Chamfer. We had used two chamfers here, chamfer 1 and chamfer 2.
Yes, yes.
And R is for the radius. C1 means chamfer of 1 millimeter, C2 means chamfer of 2 millimeter. This is now by default it will take 45-degree chamfer. If it is 30-degree chamfer, then you have to use A, angle command.
So that is 180 minus the angle given.
Yeah, 180 minus, because you have to go always counterclockwise. Angles are measured with respect to x-axis in counterclockwise direction.
Okay, sir. Thank you.
Most welcome. Anybody else? Okay, so we'll continue tomorrow morning. Thank you so much.